I'm Matthew McCosbach, and I'll be going over P versus NP, a major unsolved problem in computer science. So, what is it exactly? But before we can understand what P versus NP is, first we should understand what P is and what NP is. So, P are any problems that can be solved in polynomial time, which would be fast. NP being solutions that can be checked in a reasonable amount of time. So, if you want to think of P as easy problems and NP as hard, that's not completely wrong to think of, but there is beyond NP, which are problems where the solution is difficult to check. And so we're only going into P versus NP because the issue here is, are NP problems able to be solved in polynomial time, or are there NP problems that are truly harder than in P? So, to go over more of P, which is polynomial time, polynomial meaning many names, it refers to the steps to solve a problem being a function of the size. So as the problem gets harder, the time it would take to solve it would scale up equivalent to that. So think of mazes or multiplication. Multiplying 2 times 2 is easy. You could find out that that's 4. But then you go higher and higher, you get into the higher digits, go like 2 million, 3 million, 5 million, so on and so forth, and multiply those out. And it may take a little more time to solve if you're not a computer. So a good way to figure out what polynomial time would be is the number of steps required that can be counted. NP, which is non-deterministic polynomial time, would be if all possible answers for a problem were checked at the same time, a solution can be found in polynomial time. And of course, we go for the worst case scenario. Now, NP complete. So these are an idea of NP, like harder NP problems. And the idea here is that these are NP problems that can fit into any other NP problem. So if an NP complete problem could be solved, then you could solve any other NP problem, which would collapse the whole class and, well, solve P versus NP. So why would we want to solve this? There's many different puzzles and data for mathematics, computer science, biology, medicine. So think of curing cancer or protein folding. Important puzzles will become easier for computers to solve if we can solve this, because then these NP problems, which are all in all those fields, would be able to be solved in a polynomial time, which means that they could be solved faster. And this would also create understanding of computation. So as I was explaining earlier with polynomial time, how much does the problem scale up as the problem gets larger? Would it be quadratic, linear, exponential? That's really the question here. So this isn't just any kind of question. This is actually a Millennium Prize problem where you can win $1 million. It's like a Who Wants to Be a Millionaire for computer scientists. 7 of these problems, P versus NP being the simplest to understand, and yet might actually help solve the other ones if solved. So let's go over a little bit of history. In 1955, John Nash, a mathematician, the first prevalence of the idea of NP problems came up, where he speculated that by sending a letter to the NSA, that cracking a sufficiently complex code would require time exponential in the length of the key. About a year later, Kurt Gödel sent a letter over to John von Neumann, who asked whether these NP complete problems can be solved in a quadratic or linear time. So jump forward to 1971, and that's when the Clay Mathematics Institute gave a formal definition of this problem. So the goal of this problem would be asking the question, does being able to quickly recognize correct answers mean there is the goal of this would be asking the question, does being able to quickly recognize correct answers mean there is a quick way to find them? So in the end, if we could solve this issue, then we could find simplicity in these problems. So what's the difficulty of it? Well, up to now, there's still no answer if P equals NP or not. Most people believe it's just obvious to tell that NP holds more problems than P, but there's no proof to actually show that. Some people actually think that P equals NP, it's just not solved, which is, again, just as valid. And some people think that it's just impossible to solve this. Ironically, P equals NP is in and of itself an NP problem.